Hello and welcome to your final installment of your little miniature exponentials unit. So we're going to learn one last new thing about exponential functions today. Also, one announcement before we get started, you will have a quiz this Friday. It's going to be over this mini unit on exponentials, so it'll be a much shorter quiz than last time, but it will be a similar style to the one we did last time. All right, so let's get started on this last section. It's actually not crazy new because you already know about exponential functions and you already know about linear functions, right? So really, all this is just applying what you know and deciding which one it is. So let's write a definition for both real quick. So linear functions, these are functions that go up or down by the same amount every time. So, remember, they have a slope. So for example, Denia adds 20 sprinkles to her ice cream every second. So it's going up by 20 sprinkles, the same amount every time. But exponential functions, they don't go up by the same amount every time. What do they go up by? Well, they go up by the same percent every time. So for example, let's say Denia's sprinkles become magic sprinkles and they start reproducing at a rate of 15% every second. So real quick, that's going to accumulate real fast and she's going to have way more sprinkles than she can even fit inside her house. Or let's say Denia's sprinkles double every second. So this is still going up by the same percent every time. What percent do you think it's going up by? Well, if it's doubling, that's basically taking the amount of sprinkles that we already have and it's going up by that amount. So it's increasing by 100% every second. All right, let's do 3 examples where we are deciding. So example 1, a newborn hippo weighs about 80 pounds. Each week, its weight increases by 5%. Let W of t be the weight in kilograms after t weeks. Is W of t a linear function or an exponential function? So all we're looking for here is, does it increase by the same amount every time, or does it increase by the same percent every time? Well, if we're going up by 5% every week, what's that going to be? Well, it's going to be exponential. So this one's easy enough. All we need to say is exponential because of that 5%. All right, let's look at a different type of example. So in this one, it says Angela, who is now a waiter. Angela, you would make a good waiter, by the way, makes $75 in tips every day. Which graph best represents the relationship between time and the cumulative total of his tips? All right, so cumulative total of his tips. So basically how much he has made total in tips. So after one day, he'll have made $75. The next day, it'll be $150. The next day, it'll be $225, et cetera, et cetera. All right, so is this total going up by the same amount? Or is it going up by the same percent every day that he works? Well, it's always going up by $75. So in this case, it's going up by the same amount every time. So that means it's going to be linear. So which of these graphs here represents a linear function? Well, it's the one that's a line, right? The one that's straight. This one is an exponential. This one looks like our coronavirus cases. So it's not going to be that one. All right, and then our last example has us looking at some tables. So we have 2 tables to look at. It says determine if the table is better represented by a linear or an exponential function. So in both cases, we have, we're increasing by the same x each time, 0, 1, 2, 3, 4. And then we have an output, or a y, that's going up by some amount. We need to determine, essentially, if these numbers are going up by the same amount every time, or if they're going up by the same percent every time. So let's take a look at this first one. We're going from 30 to 36.9. So what did we just go up by? Well, 36.9 minus 30 is 6.9. All right, you might need to do a little bit of subtraction for some of these, but if we're going from 36.9 up to 44.1, I just went up by 7.2. All right, what if we go from this one to this one? Well, that's going to be exactly 7. And what if we go from this one to this one? That looks like that'll be 6.8. All right, so clearly we're not going up by the exact same amount every time, right? But it didn't say it needs to be a perfect representative. It says which one is going to be a better representative. So roughly, these are very close to the same amount. These are all pretty close to the number 7, right? We could round all of these to 7. So even though it's not exact, we're going to say that this is going up by the same or very close to the same amount. And so this one's going to actually be linear. So if you took and plotted these on Desmos, it would look pretty close to a straight line. Now let's take a look at this next one. So I'm going up from 100 to 125. Well, that's easy enough. I'm going up by 25. All right, for this one, from 125 to 156, that one's going up by 31. All right, next we're going up by 39. And then this last one looks like we're going up by 49. All right, well, this does not look like we're going up by the same amount every time. These are much different numbers. So let's instead test to see, are we going up by the same percent every time? So if I'm going from 100 to 125, well, what percent did I just increase by? Well, I went up by 25. So 25 out of 100, what percent did I just increase by? Well, 25 out of 100 is 25%. Okay. So that one went up by 25%. Let's test if the rest of them go up by 25%. So what I'm going to do is I'm going to take 125 and I'm going to multiply it by 0.25. And when I do that, my calculator tells me that I get 31.25. And I do go up to a number that is very close to 31.25. I go up by 31. So that's roughly 25% again. All right, what's 25% of 156? Well, if I multiply that out, 156 times 0.25, I get 39. And that's the amount that I go up by. So yeah, I increase by 25% again. And then from 195 to 244, well, what's 25% of 195? So what's 195 times 0.25? Oh, well, that gives me 48.75. We said that this goes up by 49, which is pretty close to 48.75. So yeah, this one roughly goes up by 25% as well. All right, so this one looks like it's going up by the same percent every time or very close to it. So in that case, it's going to be a exponential function.